Tonight, when your phone automatically recognizes your face, you will not even blink. You lift it up, the lock icon glows, the screen opens, and your brain barely registers that anything special just happened. You do this dozens of times a day. It feels as boring and inevitable as gravity. But the real story behind that tiny circle scanning your face is far stranger, and it started with a discovery this century that quietly gave machines something they had never truly had before: a way to see a picture almost the way you do. For most of human history, only one thing on Earth could really look at the world and make sense of it: the human brain. Your eyes send in patterns of light, and millions of tiny neurons in the back of your head turn that chaos into shapes, objects, and meaning. You glance at a street and instantly know what is road, what is sky, what is car, what is child. You do not calculate it. You simply see. What you rarely think about is how insanely difficult that trick is to copy. Computers, for decades, were blind in a very specific way. They could store images. They could transmit images. They could even put images on screens more beautifully every year. But ask an early 21st century computer what was inside a picture, and you got nothing but numbers. Millions of pixels. Red, green, blue values. No dog. No face. No road. Just a sea of digits that meant nothing. How do you teach a machine to see a cat in that sea when it has never seen anything before? The obvious answer was to program it with rules. Engineers tried that for years. If there are two dark circles and a triangle in roughly this position, maybe that is a face. If there is a long horizontal line near the bottom and a rectangle above it, maybe that is a car. Rule after rule piled up. Every rule broke the moment a shadow changed, or a camera tilted, or a child stepped halfway behind a pole. Your brain shrugs off those changes without effort. Early computer vision systems simply snapped. The breakthrough that changed everything in the 21st century did not begin in a single dramatic eureka moment. It began with something that looked almost boring: building a giant picture album. In the mid-2000s, a researcher named Fei-Fei started to obsess over a simple idea. What if the real problem was not the algorithms, but the lack of a world big enough for them to learn from? She was working at Princeton and later at Stanford, surrounded by computers that were technically powerful and yet still basically blind. Humans learned to see by looking at millions of scenes from birth. Machines at the time were being trained on a few thousand carefully curated images. That gap was enormous. So Fei-Fei and her collaborators started building ImageNet. On the surface, ImageNet was just a dataset, a huge collection of images downloaded from the internet and carefully labeled by humans. A picture of a dog was labeled dog. A picture of a traffic light was labeled traffic light. But the scale was absurd for its time. Not thousands of images. Millions. More than 20,000 categories. Crowdworkers around the world clicked and tagged and sorted. By about 2010, ImageNet had quietly become the closest thing a machine had ever had to a scrapbook of the modern world. To push progress, the team did something clever. They turned ImageNet into a yearly competition. Every year, teams were challenged. Build a system that looks at these images and guesses the label. Dog or cat? Airplane or bird? The rules were simple, but the task was brutal. Early systems made embarrassing mistakes. Error rates hovered high. In some categories, the computer was basically guessing. But the scoreboard kept updating, and the world's best labs kept trying. Would you have bet, back then, that a machine could ever outperform you at simply recognizing what it was looking at? Then came the year 2012. A small team from the University of Toronto submitted an entry that did not just nudge the numbers. It smashed them. The system was called AlexNet, named after lead researcher Alex Krzyzewski, built under the guidance of Geoffrey Hinton with teammate Ilya Sutskever. Instead of using delicate hand-tuned features written by programmers, AlexNet used a deep convolutional neural network. That phrase sounds intimidating. In plain language, it means this: layers of simple, neuron-like units, each one looking at small patches of the image, passing information forward, building up from edges to textures to shapes to full objects. A stack of tiny pattern detectors, trained not by rules but by experience. This idea had roots in neuroscience from decades earlier, in work by scientists like David Hubel and Torsten Wiesel, who recorded neurons in cat visual cortex and saw that some of them responded to simple edges. But in AlexNet, that biological inspiration finally collided with modern hardware and data. Fei-Fei Li's ImageNet provided millions of labeled images. NVIDIA's graphics processing units, built for video games, suddenly became the workhorses that let AlexNet train for days on end. The network adjusted its internal weights again and again. With each pass, it made slightly fewer mistakes. When the competition results were released, AlexNet's error rate was dramatically lower than anything before it. In some categories, the computer's guesses suddenly looked uncannily human. In the community, this was the moment many researchers now point to and say, that is when modern computer vision truly began. It was not the first neural network. It was not the first time someone had tried to mimic the brain. But it was the first clear, public, undeniable proof that a deep network, trained on a massive dataset and powered by commodity GPUs, could see patterns in images far better than the old handcrafted systems. If you had checked your phone that day, nothing would have seemed different. No new app on your home screen. No pop-up warning you that the visual world had just tilted. And yet, from that point on, the way machines learned to see was never the same. The next few years were a blur. Teams around the world rushed to build deeper and more efficient networks. In 2015, a group at Microsoft Research Asia, led by Kaiming, introduced something called residual networks, or ResNets. Again, the phrase sounds abstract. In practice, it solved a very real problem. When you make a neural network very deep, it can actually get worse, like a student confused by too many lectures. ResNet added shortcut connections that let information skip layers, as if some neurons could whisper directly to distant partners. Suddenly, networks could grow to hundreds of layers without collapsing. On ImageNet, ResNet surpassed human-level performance on some benchmarks. The machine was now, in a narrow sense, better than you at recognizing what was in a random photo. What do you do with a power like that? You are already living inside the answer. Every time your smartphone unlocks, by comparing the live image of your face to a stored pattern, it is using a descendant of these networks. When you search your photo library for beach, or birthday cake, or your dog's name, and the right images appear as if by magic, a deep vision model is scanning pixels for meaning. When a car in front of you suddenly slams on its brakes, and your own vehicle beeps and flashes, and perhaps even brakes by itself, a camera and a neural network have just recognized the boundary between safe and catastrophic. The discovery that started with abstract contests and research papers now sits quietly behind your camera lens, your map app, your social feeds, your security systems. You rarely see it, but it constantly sees you. Think about social media for a moment. When a platform like Instagram, TikTok, or YouTube decides which video to show you next, it is not just counting likes. It is looking at the content itself. Computer vision systems scan thumbnails for faces, text, colors, and patterns that might hook your attention. They detect objects and scenes. They flag graphic violence or nudity, trying to keep some line of safety. Some systems even estimate how long your gaze is likely to linger. The same basic architectures that once tried to distinguish a cat from a dog in a lab competition now help decide what flows into your brain when you are tired at midnight. Have you ever felt like the algorithm knew your taste a little too well? Healthcare is another place where this quiet visual revolution is reshaping your world. In eye clinics, deep learning systems trained on retinal images can spot the early signs of diabetic retinopathy, sometimes as accurately as human specialists. In radiology, models analyze X-rays and CT scans, circling suspicious nodules or fractures that a tired human eye might miss. In 2016, a paper from DeepMind and Moorfields Eye Hospital in London showed that a deep learning system could recommend referrals for a range of eye diseases with performance comparable to leading experts. The same pattern recurs. Feed a network millions of labeled medical images, let it learn its own internal representation of what disease looks like, and you get a new kind of second opinion. Not perfect, not magic, but a powerful extra set of synthetic eyes. Would you trust such a system to look at your scan? Even the skies above you are watched through this new lens. Earth observation satellites capture continuous streams of images of forests, oceans, and cities. Deep learning models sift through them to detect illegal deforestation, track melting glaciers, estimate crop yields, or monitor pollution. Organizations and startups combine these vision systems with climate models to forecast floods or wildfires. When you see a colorful map of air quality or a time-lapse of shrinking ice sheets, some part of that picture was likely sorted and labeled by an algorithm that learned in the ImageNet era. What once was a blind stream of pixels from orbit is now a living, searchable record of the planet's surface. Of course, giving machines the ability to see more like you also opens up darker possibilities. Face recognition systems, built on deep networks, can match your image against huge databases in milliseconds. Governments and companies can track where you walk, shop, protest, or pray. Cameras on street corners and in stores feed into algorithms that claim to read emotion or intent, even though those claims are often shaky. Deepfake generators can paste your face onto someone else's body, or make you appear to say words you never spoke. The same architectures that detect a tumor can also generate a synthetic smile on command. Do you feel safer or more exposed, knowing that cameras paired with neural networks might be watching you almost everywhere you go? Researchers are painfully aware of this tension. Fei-Fei herself has spoken often about the need for human-centered AI, reminding the world that technology has to respect context, culture, and rights. Others work on privacy-preserving methods, trying to train models without exposing individual identities. There are debates over bans on face recognition in cities, audits for biased vision systems that misclassify darker-skinned faces, and guidelines for how police or employers can use these tools. The discovery that let AI start seeing like your eyes did not come with built-in ethics. Those are choices you and your society still have to make. The same neural network that can help a blind person navigate a street can also be used to surveil a crowd. Which version becomes normal is not a technical inevitability. It is a human decision. Meanwhile, the underlying science keeps evolving. In 2020, researchers at Google introduced the Vision Transformer, or ViT, adapting the transformer architectures that revolutionized language models to images. Instead of scanning small patches in a fixed grid the way classic convolutional networks do, transformers break the image into patches and let every patch attend to every other, learning long-range relationships. Again, the jargon can sound alien. But the core idea is familiar. Mimic, in a crude mathematical way, the brain's ability to connect distant pieces of a scene. A face is not just eyes and a mouth. It is the relationship between them. New architectures keep blending inspiration from biology, statistics, and raw computational power. You see only the polished result: smoother filters, sharper photos, smarter crops. Quietly, these systems are changing how you remember your own life. Photo apps auto-select best images from a burst, guided by learned notions of sharpness, smiles, and open eyes. They generate memories, collections that group years of pictures into neat stories. You do not personally choose which snapshots become the canonical version of your past. A vision algorithm does. Some cameras now apply real-time enhancements tuned to local beauty standards, lightening or smoothing or reshaping faces before you ever see the raw pixel data. When you look back in 10 years, you may not be sure what your world really looked like, and what it looked like according to the network. How comfortable are you with an invisible co-editor sitting between you and your memories? There is another, more intimate way this discovery has changed you. By seeing patterns in images at scale, these networks have allowed other AIs to understand your gestures, your handwriting on a tablet, the arrangement of objects on your desk. Robots in warehouses use cameras and vision models to pick up packages. AR headsets recognize surfaces and anchor virtual objects. Gaming consoles track your movements without controllers. The boundary between online and offline has blurred because the camera turned into a universal sensor, and the network behind it turned into a universal interpreter. What used to be a one-way lens from the world to your screen is now a two-way dialogue between your actions and the machine's expectations. And yet, for all the drama, the core insight remains surprisingly humble. Instead of trying to hand code what a cat or a road or a tumor looks like, researchers decided to let a flexible, layered system discover those patterns for itself, given enough data and feedback. They bet that if you built a structure loosely inspired by the brain's visual cortex and fed it a digital version of the visual world, something powerful would emerge. From ImageNet's labeled millions to AlexNet's shocking victory, from Kaiming's ResNets to today's vision transformers, that bet has reshaped your everyday reality. You do not need to know the math to feel the impact. You just need to look at your unlocked screen, your auto-tagged photos, your car's warning light, your favorite app's endless parade of images. One day, future systems may see in ways that make even your own visual experience feel narrow. They might combine infrared, depth, radar, and microscopic detail into a single coherent picture. They might watch over coral reefs, factories, or entire city grids with a level of attention no human could sustain. But their origin story, in this early slice of the 21st century, is simpler and stranger. It is the story of a world that poured its images into servers, of a few key researchers who insisted on learning instead of rules, and of a set of algorithms that slowly, iteratively, taught themselves what you once thought only a brain could know. Tonight, when your phone automatically recognizes your face, you will still probably not even blink. But now you know that behind that casual moment stands a chain of discoveries that quietly gave machines a way to see almost like you do, and a question about how you will live with eyes that never tire, never look away, and never forget what they have seen. If you liked this video, do like and subscribe to this channel. Comment below on which scientist would you like to watch next.